Now let's go over the topic of function notation. So this f right here, that's going to be the name of the function. Sometimes your functions are called g or h or just other letters, but that's the name of the function. And then this of x right here, that just means that you're inputting something in where the x goes on the function. So if I have f of 2, if I have a 2 here, then I'm going to put a 2 right here in the radicand. So you'll have 2 squared minus 1 underneath the square root symbol. And so what this does, when you see function notation, it's giving you directions that tell you what to do with your input x in order to produce the corresponding output f of x. Namely, in this example, we square it, then we subtract 1, and then we take the square root of the result. Now let's look at example 7 for an example of function notation. Let g of x equal negative x squared plus 4x minus 5. Find each of the given outputs. So for part A, we have g of negative 2. Well, this is going to equal, everywhere that you have an x in g of x, you're going to plug in a negative 2. So we have negative, I'm going to put parentheses, negative 2 squared plus 4 times negative 2 minus 5. That's going to equal, well, we have negative order of operations. We're going to take care of what's in the parentheses first and then exponents, PEMDAS, right? So inside the parentheses, we have a negative 2 and we're squaring it. So that's going to become positive 4 and we have a negative in front of that. And then we have, for our next part, we have 4 times negative 2, that's minus 8. Then we have minus 5. That equals negative 4 plus negative 8 and negative 5 is going to give us negative 17. So that's our answer. For part B, we have g of x plus h. Notice the difference here is that we're not inputting a number, but we're inputting another expression. And that's perfectly fine. We can do that. We're just going to replace x with x plus h. So we have negative. We're going to open up some parentheses. And we're going to put in place of x, x plus h. We're going to square it, plus 4 times, open up our parentheses, x plus h minus 5. And then we can simplify it. So I have negative. We're going to take care of the x plus h squared. So if you want to do the shortcut, you can just do x times x is x squared. And then we have x times h twice. So that's going to be 2xh. Plus h squared. And if you don't want to do the shortcut, I'll just show you how I got that. So we have x plus h squared. That's just equal to x plus h times x plus h. And we just do FOIL, or distribution. FOIL is just another word for distribution of binomials. But we have x times x, that's x squared. And then we're going to do the outer ones multiplied, so x times h. That's xh. H times x, that's hx. And then we have h times h is h squared. And then because of the commutative property, xh is the same thing as hx. Think about it. 2 times 3 is the same thing as 3 times 2 is 6. So we can just write this as plus 2xh. And then we have plus h squared. All right, so that's that part explained. And then we have, we can go ahead and distribute this 4 times x here is going to be 4x. And then we have 4 times h, that's 4h. And we have minus 5. That's going to equal, we have negative x squared. I'm distributing the negative now to everything that's inside this trinomial. We have 3 terms here. This is a trinomial. I'm just distributing the negative, which is going to change the sign. So we have negative x squared minus 2xh minus h squared plus 4x plus 4h minus 5. And there's nothing else here that we can simplify. We don't have any like terms. And again, like terms are going to be any variables that have the same variable and same exponent. We don't have that anywhere on here, or just if you could combine numbers, but we don't have that either. So this is simplified. All right, let's look at part C. Part C, we have g of x plus h minus g of x. So in this case, we've already done all the work. If you look at part B, we have g of x plus h. Now we need to just take what we got there and we need to subtract g of x, which is just your entire function that we have up here. So this is going to equal, I'm going to write it here so we don't run out of room. We're going to have negative x squared minus 2xh minus h squared plus 4x plus 4h minus 5. And then we're going to have minus. Now, I'm going to run out of room, so I'm just going to verbalize some of this. I'm doing minus everything that we have right here for g of x. That's going to change the sign of everything that we have in here. So this minus x squared is going to become a plus x squared. This plus 4x is going to become minus 4x. And this minus 5 is going to become plus 5. And then we can simplify. So I have minus x squared and plus x squared. I have plus 4x minus 4x. Those are canceling. I have minus 5 and plus 5 that cancel. So I'm left with, for my output, negative 2xh minus h squared plus 4h. Now, one thing that I would like to point out here is that for part A, our input was a number. Our input was negative 2. And so notice that our output was also just a number, negative 17. But for parts B and for part C, our inputs were expressions. So The difference is if you look at the output, if you look at part B, we get an expression. We don't get a single number. Same thing on part C. Our output is an expression, not a number. So whenever you input a number, your output's going to be a number. When you input an expression, your output's going to be an expression. Now it's time for you to get some practice using function notation. I would like you to please pause your video and work out this you try it example. Once you have finished evaluating your function f at the different inputs, please unpause your video and check your solutions with mine. So here's my solution. For part A, we have f of 1 plus 3. And we can actually simplify this first. So this becomes f of 1 plus 3 is just 4. So this is f of 4. And that equals, so we're going to plug in 4 everywhere that there's an x on our function f of x. So we're going to have 5 times, instead of x squared, we have 4 squared. Minus 2 times, instead of x, we have 4. And plus 1. And then we can simplify this. And we have 5 times 4 squared. So 5 times 4 squared is 16. Minus 2 times 4, so minus 8. Plus 1. That equals 5 times 16 is 80. And then we have minus 8 plus 1 is minus 7. So our output here is 73. So notice here that our input was the number 4 and our output was the number 73. And you remember from the last example, I mentioned that if you input a number, your output's going to be a number. If you input an expression, your output's going to be an expression. Let's look at part B. For part B, we have f of 1 plus f of 3. This is going to equal, well, we're going to do f of 1 first. That just means that we plug in 1 for every x on f of x. So that's going to be 5 times 1 squared minus 2 times 1 plus 1. And then we're going to add to that f of 3. So that's going to be plus 5 times, instead of x, we're going to do 3 squared. Minus 2 times 3. Plus 1. That equals 5 times 1 squared, so 1 squared is just 1, times 5 is 5, minus 2 times 1 is 2, plus 1, plus 5 times 3 squared. So 5 times 3 squared is 9. So we do 5 times 9 is 45. So plus 45. And then minus 2 times 3, so minus 6, plus 1. And then we just need to simplify it. So this equals 5 minus 2 is 3, plus 1 is 4, plus 45 is 49, minus 6 is 43, plus 1 is 44. So notice again, our inputs for each of these, for f, we have f of 1 and f of 3, they're both numbers. And then our output, when we combined it together, was 44, another number. Another thing that I want you to notice is that f of 1 plus 3 is equal to 73, but f of 1 plus f of 3 is equal to 44. So these are not equivalent. So what we can say then is that f of 1 plus 3 is not equal to f of 1 plus f of 3. In general then, f of a plus b is not equal to f of a plus f of b, because we found a counterexample here. And all it takes is one counterexample to disprove something. Now let's look at part C. For part C, we have f of x plus h minus f of x over h, where h is not equal to 0. Why do we have to make the statement that h is not equal to 0? Just think about it for a second. Can we divide by 0? So we know that division by 0 is undefined. So that's why we have to make sure that we put in that little statement, which is actually the domain right there, that h is not equal to 0. So it could be any other number. So let's go ahead and evaluate this. So we have, this is going to equal f of x plus h is going to be 5 times, instead of x, we're going to have x plus h squared. And then we have minus 2 times, instead of x, again, we're going to put x plus h. So 2 times x plus h. And then plus 1. And then we need to subtract f of x. So we're going to go ahead and put that in parentheses so we don't make any mistakes. And f of x, we're not making any substitutions here. So we can just go ahead and write that as f of x squared minus 2x plus 1. And then that's divided by h. So that's going to equal 5 times x plus h squared, just like we saw in the last example. I'm just going to do the shortcut here because I don't have room. But we have x squared plus we have x times h plus h times x. That's just going to be 2xh. Plus h squared minus, we're going to distribute this 2 to the x and the h, so it's 2x minus 2h and then we have plus 1. And then the minus that we have right here in front of the 5x squared minus 2x plus 1 is just going to change the sign of each of these. So it's just getting distributed. So we have minus 5x squared plus 2x minus 1. And that's all divided by h. And that equals. So notice here that I'm out of room. I'm going to go ahead and distribute this 5 to the first part of our expression right here. And I'm just going to write it at the top, maybe in a different color so that we don't get lost in this mess that we have here. So 5 times x squared is 5x squared. And then we have 5 times 2xh is going to be, we have plus 10xh. And then we have 5 times h squared is going to be plus 5h squared. So now we can go ahead and cross out anything that cancels. So notice we have a positive 5x squared. That's going to cancel with negative 5x squared. And then we have a negative 2x. That's going to cancel with positive 2x. We have a positive 1. That's going to cancel with negative 1. And so notice here now that we have the 10hx left. We have 5h squared, and we have minus 2h, and that's all divided by h. So again, because I'm out of room, I'm going to have to do the canceling in this step as well for that. So since we have an h in the denominator, and each of our terms in the top has an h, this is 10xh, 5h squared, and minus 2h, we can actually take out a factor of h. So from the 10xh, I'm going to take the h that's there. From the 5h squared, I'm going to take away one of the h's, and we're left with just one power, one of them. And then from the minus 2h, I'm going to take away an h. And from the denominator, we're going to take that h away. So this is going to equal 10x plus 5h minus 2. The last thing that I want to mention about part C is that the expression that you see here, this is called the difference quotient. And the difference quotient is something that you're going to see when you get into calculus a lot, whether it's business calculus or just regular calculus. Geometrically, it's the slope of a secant line to a curve. And what you need to know about calculus is that half of calculus, you're dealing with slopes. The other half is area. And what's really cool is you just got some experience simplifying a difference quotient. So you just did some calculus and you didn't even know it. Now let's look at example 8. This is a nice application problem of function notation. If you are a single person in Connecticut in 2017 with a taxable income of X dollars and X is less than or equal to 50,000, then your state income tax, T of X, was determined by the rule. So we have this piecewise function, T of X equals 0.03x if X is between 0 and 10,000, or 300 plus 0.05 times X minus 10,000 if 10,000 is less than X is less than or equal to 50,000. You are asked to find the income tax paid by a single person with a given taxable income. So for part A, for the taxable income of $9,200. So what this is asking for is T of $9,200. So notice that since this is a piecewise function, there are two different expressions that you can plug 9,200 into. And so we need to choose the correct one based on the domain. So we need to figure out which domain 9,200 fits into. This side right here, this is the domain for each of our pieces. This is the domain. So we want to figure out, let's see, the first one is that X is between 0 and 10,000. And isn't it true that 9,200 is between 0 and 10,000? We have 0 less than or equal to 9,200. Less than or equal to 10,000. That is a true statement. So we're going to pick the first equation. So this is going to equal 0.03 times, instead of X, we're going to put 9,200. That's going to equal $276. Now let's look at part B. This time the person's taxable income is $30,000. So we know that 30,000 is greater than 10,000. And we can even write down the inequality to make sure it makes sense. So does it make sense that 10,000, we're using the second one since we know it doesn't fit into the first one. Let's try the second one. So we have 10,000 less than, instead of X, let's plug in 30,000 and see if that makes sense. We have 30,000 less than or equal to 50,000. And that makes sense. 30,000 is between 10,000 and 50,000. So we're going to use the second equation. So T of 30,000 equals 300 plus 0.05 times, instead of X, we're going to put 30,000. We have 30,000 minus 10,000. That's going to equal $1,300. So $1,300. That's how much a single person who makes $30,000 gets taxed. Now it's time for you to get some practice applying function notation to a piecewise function. So notice here that you have the same formula and same scenario from example 8, but this time you're asked to find the income tax paid by a single person with two different taxable incomes. So I'd like you to please pause your video and go ahead and work this problem. Once you're done finding your solutions, please unpause your video and check your answers with mine. So here's my solution. For part A, we're asked to find the income tax when somebody makes $48,750 a year. Notice that that falls into the second domain here. It's between 10,000 and 50,000. So we're going to use that formula. So we're going to have T of 48,750 that equals 300 plus 0.05 times X minus 10,000. Instead of X, we're going to put 48,750. So 48,750 minus 10,000. That equals 2,237.50. So $2,237.50. Now let's look at Part B. Here we asked to find the income tax paid by a single person with the taxable income of $7,345. So you should have noticed that that falls on the first domain. So we're going to use the first formula, 0.03x. So T of 7,345 equals 0.03 times 7,345 that equals 220 and 35 cents. So $220.35. That's how much income tax a person who makes $7,345 a year can expect to pay. Let's look at another application problem for function notation. For example 9, we're told, suppose the projected sales in thousands of dollars of a small company over the next 10 years are approximated by the function s of x equals 0.07 x to the fourth minus 0.05 x cubed plus 2x squared plus 7x plus 62. So that's a big function. Where x equals 0 corresponds to the current year. For part A, we are asked, what are the projected sales for the current year? So here it tells us that x equals 0 corresponds to the current year. So for part A, it's really asking us for s of 0. So that's going to equal 0.07. Instead of x to the fourth, it's going to be 0 to the fourth. Minus 0.05 x cubed, but instead of x, we're going to put 0. Plus 2x squared, but instead of x, we're going to put 0. So it's going to be 2 times 0 squared. So it's going to be 2 times 0 squared plus 7x, but instead of x again, we're going to do 0. So 7 times 0. And then plus 62. Well, it's easy to see here that everything that has a 0 is just going to cancel out because you're multiplying by 0. So we're just left with 62. But remember, here it says that the projected cells, this is in thousands of dollars. Thousands of dollars. So the projected cells for the current year is $62,000. And then for part B, it asks, what will the cells be in 4 years? So that will be S of 4. Which will equal 0.07 times 4 to the 4th plus minus 0.05 times 4 cubed plus 2 times 4 squared plus 7 times 4 plus 62. That's going to equal, remember this is in thousands when you go to calculate this, 136,720. Now it's time for you to get some practice on a similar application problem. I would like you to please pause your video and work out this you try it example. Once you are done finding your solutions for part A and B, please unpause your video and check your solutions with mine. So here's my solution. The problem says that a developer estimates the total cost of building X large apartment complexes in a year is approximated by A of X equals X squared plus 80X plus 60, where A of X represents the cost in hundred thousands of dollars. So for 4 complexes, that's just going to be A of 4. And so we have 4 squared plus 80 times 4 plus 60. And hundreds of thousands of dollars, that comes out to $39,600,000. For part B, we have 10 complexes. So that's going to be A of 10. That equals 10 squared plus 80 times 10 plus 60, which equals $96 million. So in order to build 10 apartment complexes, that's going to cost the developer an estimated $96 million. Well, that brings us to the end of this lesson. Thank you for watching.